You might be saying to yourself, revenue is not the only thing that should be looked at in this problem, and I would agree. Here would be maybe a follow-up question or a variation on the problem that we were just doing that might be of interest to you. So continuing with the $52 for an oil change and 60 changes per week, let's add this to our problem. And it goes like this. If the oil, filter, and labor costs to the garage owner per oil change are $36, what price will maximize the total profit for the garage owner? So that's a slightly different problem. There now we're figuring in the cost of materials and labor in our oil change. So when we introduce variables now, we're going to change them just a little bit in this situation. We're going to say let X represent the number of $2 price increases all over again, but we're going to let P represent the total profit. Now going back to the table of values to try to establish a relationship between P and X, we get this. If we have increases, we examine profit, and when I say profit, it's going to be profit per oil change. And units, we have the following. If there are 0 price increases made, the profit will be calculated by taking the $52 charged for an oil change and subtracting the $36 for the cost of the oil, filter, and labor. And so the net profit is simply going to be $16 per oil change. And at that point, you would have 60 oil changes completed. Now, if we increase by 1, our profit goes up by $2 because there's no increase in the cost of the oil, filter, or labor. Anything that we add on to the price at that point is pure profit. The profit would change to 18. The units would drop to 55. And at 2, the profit would now be $20 per oil change, and the units would be 50. So for X increases, the profit will be 16 plus 2X. The units will be 60 subtract 5X, and our profit equation looks like this. Profit is unit profit times units sold. Well, once again, we're going to go after those x-intercepts. And that's, again, a really easy process because it's already factored. So we say 16 plus 2x equals 0, x equals negative 8, and the second, well, it's the same x-intercept we had last time because the units sold hasn't changed. Graphically, it looks a little bit different. Our intercepts have now shifted to be negative 8, 0, and 12, 0. And once again, recognizing that we need to find the vertex, which lies on that axis of symmetry, halfway between those two x coordinates, we average the two x-intercepts, which are negative 8 and positive 12, and we get an answer of 2. The difference in this situation is the x-coordinate of the vertex is positive, so we're now looking at a situation where it's better for the garage owner to increase his price. And so the profit value at that point will be 16 plus 2 times 2, times 60 subtract 5 times 2, and we get an even $1,000. So at that point, if we want to determine the unit price or what the garage owner should charge for an oil change, we look at the 52 plus 2 times 2, which is 56. In other words, the price of an oil change should be increased to $56, reducing the number of oil changes to 50 per week, and maximizing the profit at $1,000. So two very, very different questions. One, optimizing revenue or maximizing revenue. The second, optimizing or maximizing profit. And we get two very different answers. One involves a price decrease and one involves a price increase. So when you encounter a problem styled like this, it's important you recognize whether you're dealing with revenue or profit. And then it's a pretty direct path to the vertex. Thanks for watching.